Hi students, I am Sumalata. In today's class, I am going to start a new lesson, classification of elements, periodic table. Before going to our lesson, just have a small introduction around you. Okay. The first thing, if your mama not at home, she's somewhere, she's outside for some work. At that time, what you have to do, you need to prepare your food. Don't say like this, ma'am, we are going to order through online for Swiggy or Zomato. Don't say like that. You are going to your kitchen for preparing your favorite dish maybe. So you are searching all ingredients for that particular dish. But you are facing some difficulty to find out all those things for that dish. So what you have to do, immediately you are going to call to your mama. Mom, where you are kept all those things? I am facing difficult to find out all these things. Just let me know, I am getting late. So immediately your mama tell, you can search left side cupboard, you can find out all type of dals, or you can search right side of cupboard, you will find out all powders, and you can search top of the cupboard, bottom of the cupboard, like that. Yeah, and then after you can find out all those things after calling to your mama. Then you can you can prepare your favorite dish. The finding of things in your kitchen, it is difficult for you, but your mama, it is not difficult. What is the reason behind this one? In the same way, if you go to a medical shop, in a medical shop, vast number of medicines are there. Is it necessary to remember all those medicines names for a shopkeeper? No, it's not possible. But if you go to the medical shop with a prescription, he can give all medicines, all prescribed medicines without being any confusion and without late also. What is the reason behind this? In the same way, if you go to the supermarket, you are observing arrangement of goods in particular places. If you searching for your grocery items, you can easily find out them. What is the reason behind this? And one more thing, if you go to the library, particular department books are arranged in that particular places. Maths, all mathematics books are in one place. All science books, or zoology, or chemistry, biochemistry, organic, inorganic, history, something, so many books. But you are facing difficult to find out your need, which book you want. At that time, if you take librarian's help, he or she maybe, they will help you. They can easily take out that book and they will issue to you. What is the reason behind this? So you can't able to find out easily, but they can easily find out. From all these observations, what you have understand, any system having certain type of things needed, certain order of arrangement is essential for them. Okay. In the same way, in earliest days, scientists also thought about chemical elements. They are trying to classify in minimum groups all chemical elements based upon their properties, maybe physical or chemical properties. Now coming to our topic. Here in the year 1661, Robert Boyle, 1661, Robert Boyle, he stated about element as anything we can't able to further divided into simpler units in chemical way or physical way. He stated like that. At his time, about 13 elements were there. After Robert Boyle, Lavoisier time, 11 elements are there. Okay, more 11 elements were find out. After Lavoisier, in the year 1865, another 63 elements were find out. After 1865, 1940, okay, approximately 90 1 elements from natural source and 17 elements from synthetically discovered or man-made sources or artificial elements. But for now, more than 118 elements were there. Is it possible to remember all those elements, chemical properties, physical properties, their names, their numbers, their mass numbers and their compounds? It's not easy, that much of easy to remember. So that scientists are classify all these elements based upon their physical and chemical properties. Okay, here after this, at the time of 18th century, the scientist Louis Prost, he stated hydrogen is the building block for all atoms of elements. Okay, for at that time, for all elements, atomic masses are numbers, they are in whole numbers. But for hydrogen, that is 1. We have to consider 1. After this, scientists are trying to classify elements in so many ways. In that one, first one you can see Greek's classification. According to Greek's classification, they suggest all matter in this universe divided into 4 elemental states. Those are nothing but earth, air, water and fire. But this is not the right way of classification. The next classification is the valency classification. From this classification onwards, we have an idea about how much importance is there for valency of an element. Okay, actually some elements are showing +1 valency, some elements are showing +2 valency, some elements are showing +3, like that. If elements are showing +1 valency, those are nothing but monovalent. If elements are showing +2 valency, those are nothing but divalent. If those are showing +3 oxidation state, those are nothing but trivalent. See here, +3, +1 or -1. Okay, divalent is nothing but +2 or -2. Trivalent is nothing but +3 or -3, like that. See, actually Cl minus Na plus, these are comes under as a monovalent. Divalent you can see Mg plus 2 Ca plus 2, these are the divalent atoms, and trivalent you can see Al plus 3. Okay, next Fe plus 3. But if you observe, this Al plus 3 can show +1, +2 and +3 also. This iron also show +1, +2, +3. But at that time, scientists are not having clarity about this. This iron comes under as monovalent or divalent or trivalent. In the same way, aluminium also comes under as monovalent or divalent or trivalent. This is one drawback. Another one is, here see, this chlorine having -1 charge and this sodium having +1 charge. Actually, this chlorine is completely different from sodium. This chlorine is a completely electronegative atom, and sodium is a completely electropositive atom. But those are comes under as a same classification. So that this is also not the sufficient classification. After valency classification, another classification was metals and non-metals. Metals and non-metals. Here see, some elements are showing metallic character. Those are nothing but sodium, lithium, potassium. Okay, these elements are comes under as a metallic elements, and some elements are showing non-metallic character. Those are sulfur, chlorine, bromine, iodine. Okay, these elements are comes under as a non-metal. But for some elements are showing both metallic and non-metallic nature. Those are silicon, boron, tellurium, tin. Okay, if you take these elements are showing both metallic as well as non-metallic characters, so that at that time there is no clarity about this where should we put this type of elements. This type of elements are nothing but metalloids. Okay, so after that scientists have thought that this is not the enough to classify all elements present, all chemical elements. Okay, so they are thinking, they are changing their ways. They are trying to classify all elements in the way of by concentrating on physical and chemical properties of the elements. After that, another classification was the Dobereinius law of triads. Actually, in the year 1829, he proposed this classification. He was the German chemist. So according to his classification, actually he is concentrate on especially he is trying to correlate between atomic weights and chemical properties of elements. I mean, as per Dobereinius, if you take three elements are showing similar chemical properties, if you are arranging those three elements into increasing order of their atomic masses, the middle element's atomic mass is approximately equal to the first and third element. Okay, so at that time these three elements are called as the triads. This law is nothing but the Dobereinius law of triads. Okay, you can see some examples. See, calcium, strontium, barium. Calcium is the 40, strontium is the 87, barium is the 137. So say this is the middle element, this is the first element, and this is the third element. So you can take arithmetic mean for first and third element. So what is the total value? 137 plus 40 is equal to 177 divided by 2. So 2 8 ja, 2 8 ja, 2 5 ja, 10. So see, this is the 88.5 and this is the 87. Actually he said approximately equal to the middle element's atomic weight, not exactly, so that this is the near number to this one, so that it is I mean, we can call these three elements as a one triad. You can take one more example, lithium, sodium and potassium. See, lithium is the 7 atomic mass, sodium is the 23, potassium is the 39. See, this is the middle element. You can take total for first and third element, then you will get 46 divided by 2. 2 2s are 2 3s are. See, this one is exactly equal to the middle element. So we can tell these three elements also a one triad. In the same way, one more example you can take, chlorine, bromine, iodine. Here chlorine's atomic mass is the 35.5, bromine's atomic mass is 80, iodine's atomic mass is the 127. So now you can take arithmetic mean for first and third element. 120 plus 30, 150, 150 plus 12, 162.5 divided by 2 is equal to, see, 2 8 ja 16, 2 1 ja 2 2 ja 2 5 ja. See, this is also not exact number, approximately equal to the middle atom's atomic weight. So this one also we can tell as a triad. Up to this extent, okay. Is it applicable for all well-known elements at that time? No, it's not applicable for that one. It is limited for some elements only. That is one drawback. not applicable for all well-known elements at that time. Okay, that is the first drawback. Another drawback is it can't able to apply for higher atomic mass elements and for also lower atomic mass elements. Suppose you can take fluorine, chlorine, bromine. Actually, fluorine's atomic mass is 19, this is 35.5, this is 80. So you can take arithmetic mean for these two elements. So 99 divided by 2. 2 4s are 2 9s are 2 5s are. See, this is not the at least near number to 35.5. So that these three are not the triad. These two are the main drawbacks of Dobrinier's triadic law. Actually, from Dobrinier experiment, we have a clue one thing, that is what atomic weight maybe take a major role on classification of elements. Maybe atomic weights and physical or chemical properties may be correlated with each other. From then onwards, scientists have trying to concentrate on atomic weights. The next classification was the Newland's law of octaves. We will say about that one. Actually, this classification was proposed in the year 1865. He was the Greek scientist. According to Newland, actually he is a lover of music. First, you know about musical notes. 7 musical notes are there. Based upon musical notes, he tried to classify elements. How is that? We can see now. You can see first musical notes. See, first of all, Indian musical notes: sa, re, ga, ma, pa, da, ni. See, this is the 7th one, students. So again, 8th one will comes as sa. These are the Indian musical notes. You can say about Western musical notes: do, re, mi, fa, so, la, ti. See, again you will get do here. This is the 8th one. 1, 2, 3, 4, 5, 6, 7, 8. See, 8th one is the similar to the first one. Just remember this. Based upon these musical notes, he tried to classify elements. If you arranging elements into increasing order of their atomic weights, every 8th element will show similar physical and chemical properties to the first element. That is the Newland's law of octave. See, you can take some examples. This is hydrogen, lithium, beryllium, boron, carbon, nitrogen, oxygen. I am going to write only 7 elements. 8th one I am going to write in the same line with the first element. See, oxygen, after fluorine. This is the 8th one. Okay, fluorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur. See, this is the 7th one, and 8th one to the fluorine is the chlorine. Okay, after that, after 8th one to the chlorine is the, see, cobalt and nickel. These two will comes under 8th to the chlorine. Just remember, after cobalt and 8th to the cobalt and nickel, bromine. After that, palladium. After that, iodine. Iodine after platinum and iridium. See, I am not writing all these things. Just remember. See, fluorine is the 8th element to the hydrogen and chlorine is the 8th element to the fluorine. Here see, these two, cobalt and nickel, are 8th element to the chlorine, bromine also 8th to the cobalt and nickel, palladium 8th to the bromine, iodine 8th to the palladium, and platinum and iridium, these two are the eighth to the iodine. Up to this extent, okay, he is saying in the same horizontal row, which elements are there, all those elements are showing similar chemical properties. If you arranging elements into increasing order of their atomic weights. But up to this one, okay, but this is not the right way of classification. Why? Because let's see limitations of this Newland's law of octaves. The first one is actually in some columns two elements are exist. What are those? See here in the first horizontal row, two elements in this column and in another column those two elements. So cobalt and nickel exist in the same column. Next platinum and iridium, those are also exist in the same column. So this is not the right way because only one element should need to there. This is one drawback. Another drawback is, say, fluorine, chlorine, bromine, iodine. These are the halogen elements. Okay, halogens. These will show similar chemical properties. Actually, when compared to halogens, cobalt, nickel, palladium, platinum and iridium, these are not the halogen elements and these are having different chemical properties with respect to the halogens, but those are arranged in the same horizontal line. So this is the another drawback of Newland's law of octaves. And another drawback is here only 56 elements were exist in his table. There was no space for newly discovered elements. This is the one more drawback. And okay, what is the main merits of Newland's law of octaves? Actually, he was the first person to identify atomic number plus points. See, he was the first person to assign atomic number to the element, but for his work neither accepted by his senior scientists nor by journals of chemistry, that was rejected. But at his time the term periodicity was generated. Periodicity is nothing but after certain intervals elements are showing similar chemical properties to the first one. That is nothing but a repetition of properties, nothing but the periodicity. These two are the merits and these are the drawbacks. After Dobereenius, scientists are concentrate on atomic number as well as atomic mass. Okay, this is about introduction and different types of classifications present in the classification of elements. We will see in the next class. Don't forget to subscribe, like, share these videos to your known people. If you have any doubts, just mention in the comment box. We will meet in the next class. Bye students. Take care.